We're solving problem 16 from the 2018 F equals MA exam B. A plane can fly by tilting the trailing edge of the wings downward by a small angle theta called the angle of attack. In still air, a plane with ground speed v will have a lift force proportional to v squared theta and a drag force is proportional to v squared. Consider a plane initially in level flight in still air with constant ground speed v. If the plane enters a region with tailwind with speed w is less than v, the wind is blowing in the same direction that the plane wants to fly. How must the engine power and angle of attack change for the plane to maintain level flight at the same ground speed? And then we have our answer choices here. And we have a kind of crude diagram I drew. But basically, imagine that this box is the plane and it's going at this angle, angle theta, which is the angle of attack. We now know we have the lift forces and the drag forces here. Lift is k sub 1 v squared theta, and drag is k sub 2 of v squared. Well, that means so from these forces, we immediately can get that because they're flying in level flight, right? From this, we get that the weight is equal to the lift force, which is equal to k sub 1 v squared theta. Similar logic here. The forward force is equal to the drag force, which is, or it's just this equal to this force, k sub 2 v squared. From this equation, we find that the angle of attack theta is equal to w over k sub 1 v squared. And then we can find out that, so we can find out equation for power, and that is that the power is equal to F times V, which is k sub 2 v cubed. Therefore, when you fly in an area of tailwind, the velocity becomes v to v minus w, the wind. So therefore, in order for this to happen, the engine power has to decrease and the angle has to increase. So therefore we have an answer, and that's C, because it's the only answer that matches our description, and we are done.